everyone, welcome to another exciting episode of Bar. I'm just kidding. Alright, so let's talk about some trigonometry. Okay. Now, as we discussed before, that if we get presented with this type of triangle, we know, well, this thing is a right triangle. How do we know that? Well, we look at this little box here, right? So as I mentioned in class, is we can relate this back to the x and the y coordinate, and then we can see, well, these lines are perpendicular, so in cases of this, I can now say, well, hey, this kind of looks like a y-axis, which will relate to my height, and then this kind of looks like x-axis that can relate to my base, so the distance between these 2 points, That's a little bit of an advanced explanation, so let me draw another one. Okay. Now, across the right triangle is the hypotenuse. The hypotenuse. And if they give you, let's say they give you the three values. Let's say the values are 4, 7, and 12. Now they ask you, how does this triangle look? They say this is in fact equal to a right triangle. Okay, I think if we add these values, they're not, but just for this example, well, we now know that the hypotenuse is the longest side of the triangle, or is the biggest side out of the three, so I can simply go plot this. The 4 and the 7 doesn't really matter in which side you put them. You can put them either side, doesn't matter. But this, the hypotenuse across from the right angle, should be 3. Okay, very simple stuff so far. So now let's get to, before we can get to trigonometry, well, something interesting about trigonometry is whenever we get introduced to this topic, it might appear to be a whole bunch of right triangles, right? But what trigonometry is actually just a whole bunch of circles, and this will later make sense. It's everything about circles and nothing about triangles. Although there's triangles involved, it more relies on your understanding of circles, especially when we get to the unit circle. So this thing is called theta, right? Theta, the angle of theta. Now, before any type of trigonometry, we need to be familiar with the Pythagorean theorem, which simply just tells us that this leg squared plus this leg squared is equal to this hypotenuse. Right, so in this case, we can simply write this in formula. Let me add c, c squared. Now my c's value in this case is x. So the c in the Pythagorean theorem would refer to my hypotenuse, while the a and the b refers to the two legs. Or again, you can think about it as your height and your base, right? Or your x and your y. There's many different interpretations, but let's stick to two legs for now. So it's just 4 squared equals x squared, and therefore we get 9 plus 16 equals x squared. Again, I'm going to shift my 2 around just because I personally like to have my variables in front. So we have 25, and then the square root of this is plus minus 5, but this step is unnecessary, by the way. You can just write 5. So it's positive 5, right? Why not negative 5? Because I'm going to reject the negative value, because it would be impossible for my leg to be, or my hypotenuse to have a negative length of, so if I say, hey, negative 5 meters is, I want a building that has negative 5 meters diagonal. It makes absolutely no sense. Okay. So this is the Pythagorean theorem. Very, very, very basic. It gets a lot more complicated when you have trigonometrical identities like sine squared x plus cosine squared x equals 1 squared. Well, here we have a trigonometrical identity, and this might seem very familiar to you, but let's skip that for now. Okay, now we're going to get to some trig ratios. So that's all that trig is, right? Trig is just a whole bunch of ratios. So we have this right triangle. Now I have theta, but I'm going to draw two thetas. Theta would be over there, and theta would be the angle of theta is over here. So there's angle 1, there's angle 2. Now, interestingly enough, this thing is called the perpendicular, right? I think they use that in Arabic, if I'm not mistaken. But for us, we will just look at which angle is across from theta. So this one is across. So that would be the opposite side. Okay, but to keep it simple, I'm going to say O. But this would be opposite side. And then we have the adjacent side, which would be right next to. So the picture I usually draw is this one. If you have two people standing, person A is standing adjacent to person B, adjacent, next to. If you have person A over there and person B over there, let's assume the guy's not upside down. Then we have AB. So then, now person A is opposite person B. Now we can think about the same of the triangle or the right triangle. Look at theta's position. Look what's opposite theta. So what is looking directly back at theta? Well, it would be the opposite. And then over here, theta is next to A. So it's next to the base, which should be then the adjacent side. So if we look at this, which side is opposite theta? Yeah. Well, we have a new opposite. See how they changed? On this one, we have the perpendicular height, which is opposite. But here, now all of a sudden, we have the base, which then could also be considered the perpendicular height, but just from a different angle. Right? And then what's next to it? Adjacent. And the hypotenuse. Now, there's something that everyone knows, which is TOA. My favorite word, TOA. Now, if we can identify from theta our adjacent, opposite, and hypotenuse, it's fairly simple to find sine's ratio. So sine would therefore, or the sine of theta, so let's put sine or sin of theta, will be equal to the opposite over the hypotenuse. Okay? So it would be this side over this side. Then we have CAH, which is cosine theta is equal to the adjacent over hypotenuse, which would be this side over this side. And then we have tangent theta, which would be equal to opposite over adjacent. And that's it. Very simple. Those are the three basic trigonometrical identities. So let's look at an example. Let's say we have special triangle 3, 4, 5. Okay, let's put theta over there. Now, I'm going to identify my positions first. If you want to make this extremely easy, you can simply label your values, right? So let's see. Right next to him means adjacent. Very good, everyone who just said that to themselves. Very good. So we can say, well, 3 is equal to the adjacent side. 4 is across, so 4 will be equal to my opposite side. And then we have 5, which will be equal to my hypotenuse. Now they can ask you, well, what is the sine of theta? Well, we know, according to TOA, it's the opposite over hypotenuse. So opposite over hypotenuse. And therefore, the sine of theta will then be the opposite, which is 4 over 5. And then if we want to calculate theta, well, to calculate theta, we need to use something that's known as the inverse function of sine. You can find this on a calculator by Casio by pressing Shift plus sine. that should give you the inverse function of sine, which appears with a little -1 as the exponent. So we can type the inverse function of sine 4/5, and we get theta's value, which I'm not too sure. I don't have a calculator with me now. Yeah, this is basic trigonometry. We'll get into some more advanced stuff in another vid.